Hello, everyone, and welcome to Chapter 4 in Algebra 2. Today, we're going to start with 4.1, Graphing Polynomial Functions. So the first thing we need to do is to define what a polynomial is. And before that, we're going to start with the definition of a monomial. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. That is the key right there. A monomial, mono means one, so it's just one term. So something like 3 is a monomial. 3x is a monomial. Even 3x squared is a monomial. Even 3x squared y is a monomial because it's just a number, a variable, or the product of a number and one or more variables. The exponents do have to be whole numbers. So if you had 3x to the 1/2, no longer a monomial. You can have the coefficient be a fraction, 1/2 x, that would be okay. You can even have the coefficient be an irrational number, square root of 2x. The only condition is on the exponent of the variable. That has to be a whole number. And then a polynomial is simply a monomial or the sum of monomial. So poly means many. So it's many monomials put together. So they gave it this really complicated looking way of writing it. A sub n, x to the n, plus a sub n minus 1, x to the n minus 1. That's just saying that they're trying to write it in descending order. So you might have 4x cubed minus 3x squared plus 11x minus 12. In other words, you want the x to the third power, and then the x to the second power, and then the x, and then the one with no x's at all. This is called the constant term because it doesn't have a variable. It doesn't vary. It's constantly negative 12. So let's practice that for a minute. Make sure you got that definition down. Decide whether or not the function is a polynomial function. If so, write it in standard form, which just means descending order. State its degree and state the leading coefficient. So I see that all the exponents are whole numbers. So I can rewrite it as f of x is equal to negative 3x to the fourth plus 2x squared plus 6x plus 1. The negative 3 is the leading coefficient. So now that it's in the correct order, the negative 3 leads. And a coefficient is the number in the monomial. So negative 3 is called the coefficient. 2 is a coefficient, 6 is a coefficient. And then it says to state its degree. So this degree would be 4. The degree of a polynomial is the highest degree of all the monomials. In number 2, we have some fractions, but that's okay. But what's going to stop this from being a monomial is this x to the negative 1. If we bring that to the numerator, it's actually an x to the negative 1, and it needs whole number exponents. So that precludes it. So this is not a polynomial. The next two, you might see that square root and think that it's not a polynomial, but it is. Okay? The coefficients need to be real, but not necessarily rational. So you can't have an I for a coefficient, but you can have a square root. So this is already in order. Its leading coefficient is the one with the highest power. So the highest power of x is x to the first. So the leading coefficient is the square root of 15. And the degree of the polynomial is 1, because that's the highest degree. On the last one, I see a 2, a 1, and no x's at all. So this one is a polynomial. I can rewrite it in descending order. Negative 2x squared plus 3x minus 2 square roots of 3. The negative 2 is the leading coefficient. And the square is the degree of the polynomial. The degree of the polynomial is 2. It is a quadratic polynomial. To evaluate a polynomial means to find the value of the polynomial for a given value of x. Please do not confuse this with the word solve, which means to find the value for x, which makes the equation true. I do not put vocabulary on your tests and quizzes, but I do put directions. And if you come up to me and say, what do you mean evaluate? I'm not going to tell you. That is part of the test question, is for you to understand the directions. So evaluate means you're going to be given a value of x and you're going to plug it in. Solve means you're going to find x. So solve is to find x and evaluate is to plug in x. So the proper notation when they say x is equal to 2 is to say h of 2. This is your way of saying, what is the value of h of x when x is equal to 2? That's the proper notation. So you can go ahead and plug that in there. And we have -8 and -8 again, and -6 plus 4. That gives me -16 minus 2, -18. So we would say h of 2 is equal to -18. Graphically, what does this mean? This means that when x is 2, y, remember this always represents y. Y is -18. If you were to graph that polynomial function, that point would be on there. Now we're going to do g of -4. If you would like to try it on your own, the answer is going to be 0. You can see if you can get that, but of course I will show you. -4 to the 4th minus 32 times -4 squared plus 256. G of -4. -4 to the 4th is positive 256. And then -4 squared is 16. 16 times 32 is -512. And then plus our 256 gives us 0. If we were graphing this, what does it mean? It means when x is 0, when x is -4, y is 0. That would be the ordered pair that would be on there on your graph. But I'm not going to box that because they didn't actually ask for that. I'm just trying to always get you to understand everything that you're learning. Okay, so you can't quite see the top of this paper, I realize, so I'm just going to kind of fill it in here. This column is going to be for a is greater than 0, and this column is going to be for a is less than 0. And these are the main types of polynomial functions I want you to know. Constant. So that means that there's no variable. It doesn't vary. It's constantly the same number. So this would be f of x is equal to a number, or y is equal to a number. It constantly stays the same. If a is less than 0, it just means that it's below the axis. So it's really hard to see the axes on here, so I'm just going to take a quick minute and draw them in. I don't know if it came out any better on your paper. Sorry to hold you up here. I just realized you really can't see them. But I think it'll make it easier for us going forward. Okay. So now a linear function, the key word there being line, is when you have y is equal to mx plus b. If it's just to follow the pattern for the rest of them, we're going to make it ax plus b. And you'll see why when we do all the other ones. And that just means that if a is positive, it's going up. If a is negative, it's going down. A quadratic function, which we spent the whole last chapter doing, is y is equal to ax squared plus bx plus c. If a is positive, your parabola is going to be going up. And if a is negative, your parabola is going to be going down. A cubic function is ax cubed plus bx squared plus cx plus d. Now, do you see why I wanted the a instead of the m? M is its only slope for a line because that stays the same throughout the whole time. This slope keeps changing depending where you are on the parabola. Look, it has a negative slope, and then it has a zero slope, and then it has a positive slope. So we don't call it m, we call it a, ax squared plus bx plus c. The very general shape of these is something like that, unless a is negative, and then it's going to end down. For the quartic graph, y is equal to ax to the fourth plus bx cubed plus cx squared plus dx plus e. And what I'm going to do is I'm actually going to add a bump to it. So 1, 2, 3, 4. Notice it ends up. 1, 2, 3, 4. Ends down. So look at the patterns here. In the column where a is greater than 0, they all end positive. The linear one doesn't really count. It just goes straight across. But it goes up, it goes up, it goes up. If a is less than 0, it goes down, it goes down, it goes down. So this determines the end behavior. Okay. The other thing to notice is that the power of x determines the number of lines, the degree of the polynomial. So if it's to the first, you should be able to draw it in one line. But if it's squared, it'll take two, one going down and then one going up. If it's cubic, the degree is 3, then look, it's kind of like 3 lines. It goes up, and then it goes down, and then it goes up again. Math has some great patterns in it. And if it's quartic, if it's to the 4th power, it's called quartic, and it goes down, up, down, up. There's four turns, so to speak. All right, this next part is a little tricky for people, and that is that we're gonna describe the end behavior, but we're gonna do it using proper notation. So this is easy in general. Ends down. Don't you love that? It's negative, it ends down. This one is not in descending order, but this is the one I'm going to be looking at. This one ends up because a is greater than 0. Let's see. This one is in descending order. It's positive, so it ends up. This one, don't be fooled. It looks like it ends down, but the degree of the polynomial is actually 8. You always have to look at the highest one. So this one also ends up. Not too bad, right? But I want to talk about it in using the proper notation. And the way you would say that is as x goes to infinity, f of x goes to negative infinity. I'll show you what that means. So this is a 6-power polynomial. So it's going to have 6 kind of turns in it. So, but I need it to end down. So 1, 2, 3, 4, 5, 6. See how it ends down? That means as x becomes increasingly large, so not here when x is 1, or here when x is 8, or even when here x is 20, but the more x gets bigger, what is this doing? It's ending down. So if you pick a really big number for x, like 100, What is the y value doing? Remember, this means y. The y is going down to negative infinity. What about as x approaches negative infinity? So as x goes in this direction, as x is becoming more and more negative, what is the graph doing? It's also going down. F of x goes to negative infinity. Like I said, I realize that this is a little tricky, but we have 3 more examples to practice on, so we'll get it. Next one. This is a 5th power. So I'm going to draw 5 lines. 1, 2, 3, 4, 5. And I want it to end up. Now you're going to have to think ahead. If this had ended down, I would have had to start from the top to make it work. So as x goes to infinity, meaning as I'm going out on the x-axis in this direction, what is the y value doing? What is f of x doing? Remember, this just means y. So as I go out in this direction, what is my graph doing? It's going up to infinity. As x goes to negative infinity, which just means in this direction, so way out here is negative infinity. As x keeps going out here, what are the y values doing? They're going down to negative infinity. All right, you still might not have it yet. That's okay. We're going to keep working on it. So it's 7th and it ends up. So since it's an odd power, I know it's going to be opposite ends, just like the 5th one was, where notice that the 6th power started and ended in the same spot, just because of the number of turns you have. So 7th, 1, 2, 3, 4, 5, 6, 7. So what's it doing? As x approaches infinity, what is the y doing? F of x is going to, oh, I guess I wrote equals up there. Should be just going to. F of x is going to positive infinity. As x approaches negative infinity, f of x is approaching negative infinity. So let's say you're really struggling with this. It's possible that you're going, why is she making a big deal out of this? I totally get it. If you totally get it, that's awesome. But when you see this as x approaches infinity, just think to yourself as the graph, or just maybe not even as the graph, but what the graph does. It doesn't want to write that small. What the graph does. Sorry, it does not want to write that at all. What the graph does on the right. That's how you can think of it. So when you see as x approaches infinity, just say over here on the right, what is the graph doing? If it's going up, then you write to positive infinity. Okay. When you see this as x approaches negative infinity, if you don't really understand it yet, you can just think to yourself, when the graph is on the left side, or what the graph does on the left side. So when the graph is over here, what is the y value doing? If it's down, if y goes down, then it's negative infinity. I don't know if that helps you a little bit. You can try the next one on your own, or you can watch me do it. So this is an 8th power and it ends up. So even powers start and end the same. So if it ends up, it also starts up. So starts up here. 1, 2, 3, 4, 5, 6, 7, 8. So what is it doing on the left? On the right? As x approaches infinity, that means what it's doing on the right-hand side, it's going up. F of x, or the y, goes to infinity. As x goes to negative infinity, you can think of that as what's happening on the left-hand side, and it's also going up. F of x goes to infinity. All right, like I said, people have a really hard time with that. So it'll be on your quiz. Make sure you understand it. Come see me. Have me do some more in office hours if you need me to, okay? Next page, number 5. Describe the degree and leading coefficient of the polynomial function using the graph. So since I see that it goes down, up, down, the degree must be 3. This is some kind of a cubic polynomial. And the leading coefficient must be negative because it ends down. So since it ends down, the leading coefficient must be negative. Now, I will say that you can't be absolutely positive that the degree is 3. It could have a little bump up there that we don't even see. So maybe we're only looking at this much of the graph and we think it's a degree 3. It might be degree 5 or 7 or 9, but it's cubic or odd. You're welcome to say either cubic or odd, but most people just tend to look at a graph like this and say cubic, but any odd function will do. So that's the end of 4.1. I'm actually going to start 4.2 today, and then there'll be another video finishing this. But as you can see, that was really short, so I combined them. And you're going to love section 4.2. It's super easy. It's actually stuff that you should already know how to do, but they throw it in there to make sure that you practice it a little bit before the rest of chapter 4. So we're just going to add, subtract, and multiply polynomials. If you're adding them, you can literally collect like terms. So I know that some of you in your elementary schools actually had boxes where you found the same terms and you put them in your little different shapes and things like that. You are more than welcome to do that. I am not going to criticize anybody for anything that helps you get the right answer. But of course, you are in Algebra 2 honors in high school now. You don't have to do that. You can just look. So I put the 4x squareds, the x squareds together, and I get negative 5x squared. I put my x's together, and I get positive 1x. You don't need to write the 1. And I put the numbers together, and I get 26. And that's the answer. So you might be thinking, what is the purpose of the parentheses? It's just to group them. It's just somebody saying, I have this polynomial, and I have this polynomial, and you're adding them together. When you're adding, the parentheses actually don't really matter. But when you're subtracting, the parentheses matter a lot. You must distribute the negative. This is going to be the biggest mistake that people will make on this. Not because people don't understand the concept. Everybody understands the concept. It's because they think they're smart enough to do it in their heads. They're like, all right, 6x squared minus negative x squared. The first time, they'll remember that it actually becomes a plus x squared, and they'll write 7x squared. But then when they go to do the second one, and definitely by the third one, they look at the 48, they look at the negative 63, and especially when it's negative and they know they're supposed to be subtracting, it's easy to accidentally just do 48 minus 63. So here's going to be my rule. Listen carefully. If you choose to do this in your head and you get it right, that's great. I will not take off points. But if you don't show the middle step and you get it wrong, there will be no partial credit, because I'm warning you that this is a huge mistake. It does not take that long to rewrite what those are. Distribute that negative. Positive x squared, negative 24x, positive, I don't know why I wrote 64, positive 63. And then cross that out. I don't even expect you to rewrite this. I mean, I'm going to rewrite it because I like my work to be tidy. But all I ask is that you write out the step where you distribute the negative. So when you add those together, you get 7x squared minus 36x plus 111. Now, these next set of problems, you might be able to do completely on your own. So I did take a minute and write out the answers. You are welcome to screenshot this page and do all the work yourself if you would like to do that. But obviously, I am going to go through it with you. One last chance to screenshot. Okay, so the first step is always distributing. These parentheses indicate multiplication. So this is being multiplied, this is being multiplied. 4 terms you're going to be distributing the 2x squared to. and that gives me 4x. We add the exponents to the fifth, minus 2x to the fourth, plus 6x to the third, minus 10x squared. Now, the same exact rule applies when you have several things that have to be distributed. I am going to distribute the x to the fourth to all three of those things. But then I'm also going to distribute the 10x squared to all three of those terms. And then I'm going to distribute the 25 to all three of those terms. So you could write this out if you wanted to. You would get 3x to the 6, distribute the x to the fourth, minus 6x to the fifth, minus x to the fourth. But instead of continuing in a big long line, what I do is I collect like terms as I go. So now when I distribute the 10x squared to the 3x squared, I get negative 30x to the fourth. I actually put it in this column. And that way it'll be easy to collect like terms when I'm done instead of having a big string of nine parts. Negative 10x squared times negative 6x is positive 60x cubed. And I don't have a x cubed column yet. So I would just write it like that. And then negative 10x squared times negative 1 is plus 10x squared. And now I'm going to distribute the 25. 25 times 3x squared is 75x squared. So it's going to go in this column. And then 25 times 6 is negative 150x. And 25 times negative 1 is just negative 25. In this case, the columns weren't that big a deal because there were only two like terms. But sometimes there's a whole bunch of them, and it really can save you a lot of time. 3x to the 6 minus 6x to the fifth minus 31x to the fourth plus 60x to the third plus 85x squared minus 150x minus 25. There you go. Now, when you have three things to multiply, you can only do two at a time. Just like if I asked you to do 3 times 4 times 5, you would never distribute the 3 to the 4 and to the 5. You'd pick 2 to multiply together. 12 times 5 is 60. Or maybe you'd pick these two. 20 times 3 is 60. You have choices which ones you put together first. The same is true here. Pick two that you want to multiply together first, and then multiply by the third one. So I'll do the first two. First, outer, inner, last. I am going to just combine those before I continue. X squared minus x minus 2 times x plus 6. So usually we distribute the ones in this factor to the other one, but this one's shorter. I think I'm going to distribute the x to those and then the 6 to those. You don't always have to do it the same way. So x times x squared is x cubed. X times negative x is negative x squared. X times negative 2 is negative 2x. 6 times x squared is 6x squared. So you may remember that I said before I like to line it up in columns. 6 times negative x is negative 6x, and 6 times negative 2 is negative 12. Makes it really easy to add. Plus 5x squared minus 8x minus 12. So again, I have to decide which ones I'm going to multiply through first. This time I picked these two. I'm going to pick these two. It doesn't matter which two you do. Make sure you rewrite the 2x minus 3. Every step has to be equivalent. First, outer, inner, last. Now, since I'm going to simplify the inners and the outers anyway, I'm also going to put it in descending order because I think that it's easier to have it in descending order. And now I'm going to distribute my 2x to this factor and then my negative 3 to this factor. That gives me 10x cubed minus 68x squared plus 48x. Now I'm going to distribute the negative 3. That gives me negative 15x squared. 3 times 34 is, what is that, 102x. And then 3 times 24 is negative 72. That gives me 10x cubed minus 83x squared plus 150x minus 72. So as you can see, I really like my little column method rather than writing them all out, but it's not required. This one looks nice and easy. We can just do FOIL. FOIL only works for a 2 by 2. If it's anything else, it's called distributing. And FOIL is distributing too. I just want to show you that that's exactly what FOIL is. I'm going to distribute the 3y to the 3y, and I get 9y squared. And then I distribute the 3y to the 8, and I get 24y. Now I distribute the negative 8. Negative 8 times the 3y is negative 24y, and negative 8 times 8 is negative 64. And somebody just came up with a name for that. First, outer, inner, last. But FOIL is just distributing. That's all it is. Anyway, these cancel, and you get 9y squared minus 64. If you ever have two factors where the terms are the same, but the sign in between them is opposite, the inners and the outers will always cancel. Okay, another opportunity to tell you about a really big mistake. This answer is not 8v cubed minus 1. You cannot distribute that cubed to both of those. Do not distribute the cube. People do it all the time. Instead, you have to write it out. 2v minus 1 times 2v minus 1 times 2v minus 1. And like numbers 6 and 7, you can only do 2 at a time. So it is going to be 4v squared minus 2v minus 2v plus 1. And even though you're not using it right now, you are required to keep writing this. Each line has to be equivalent. That gives me 4v squared minus 4v plus 1. I simplified a little bit, and now I'm going to distribute. Distributing the 4v squared first, I get 8v cubed minus 4v squared. Now I distribute the negative 4v. That gives me negative 8v squared, and then plus 4v. And then the last one, plus 2v and minus 1. For a final answer of 8v cubed minus 12v squared plus 6v minus 1. And if you had done those on your own instead of just watching the whole video, good for you. Last one for the day. In order to do this problem, you need to know that the volume of a right circular cylinder is pi r squared h. So right now you guys are all on track to move into AP. AP does not give you any formulas on their AP exam. You have to memorize everything you learn between Algebra II and calculus. So I'll show you the very easy way to know this formula. So it's a cylinder. They call it a right cylinder. A right means it has a right, which is another name for a 90-degree angle. In other words, it's not tilted. So there are pipes and things that are tilted, but ours is a right. So think of it as upright. So the area of a circle is pi r squared. And if you kept having those circles, if you just stacked them up like a bunch of coasters, if you stacked up all those circles, you would have a volume. So we're going to multiply that one coaster, that 1 pi r squared, times the height, because each coaster stacked up would make a cylinder. So given that the volume of a right circular cylinder is pi r squared h, express in terms of x the volume of a cylinder with radius x minus 2 and height x plus 3. So the volume would be pi r squared h. So pretty much they want you to multiply it out. This is going to be not x squared plus 4. Watch out. You have to actually write it out. Now, some people can still do it in their heads, and that's great. But whatever you do not distribute the square. That gives us pi x squared. Now, I am going to do the inners and the outers in my head. When you can do that, as you guys get older and more confident in math, you should try and do that. So the x squared times the x is x cubed. The x squared times the 3 is 3x squared. The negative 4x times the x is negative 4x squared. And the negative 4x times the 3 is negative 12x. The negative, or the positive 4 times the x is 4x. And the 4 times the 3 is 12. For a final answer of x cubed minus x squared minus 8x plus 12. You can distribute the pi if you want to, but it's not really necessary. All right, that is it for today's lesson. I hope you have a great day.